Hi. Okay, pre-calculus 2-5. This is part 3. Oblique asymptote. So, if you look at my previous video, there were 3 categories for horizontal asymptote. If denominator has a higher power, when they have same power, if a numerator has a higher power than denominator, I said there's no horizontal asymptote. Okay, in that case, you could end up with oblique asymptote. Sometimes we say slant asymptote. If numerator has higher power than denominator by 1. If numerator has a higher power than denominator by 1 power, then you can have oblique asymptote. We call that slant asymptote too. So how do you find that? You divide the numerator by denominator. The quotient will be equation for slant asymptote. So example of that would be slant asymptote would be something like this, oblique asymptote. And you might have a vertical asymptote, then your graph would look something like that, or graph would look something like that, depending on the equation. So let's take a look at it. Determine any asymptotes and intercepts for this graph the function. Domain, they want the domain. So first thing I'm gonna do is vertical asymptote. So I'm gonna check vertical asymptote. Before anything else, actually, can I factor numerator? Numerator is what? X squared plus x minus 8. So 1 times 1 makes 1. 2 times 4 makes 8. Okay, I realized it's not factorable. So we will deal with that later. This is a little more difficult question. It's not factorable. We will deal with that later. Vertical asymptote. So vertical asymptote is what? Denominator equal to 0. So you got x plus 3 equal to 0. So you got x equal to minus 3. You got vertical asymptote. So x equal to minus 3. And we asked the domain. So let's knock that off. Domain is x is not equal to minus 3. Okay. Horizontal asymptote. Okay. Power of x, numerator. We have a higher power on numerator, which means horizontal asymptote, there's nothing. Leave it as blank. But numerator has a higher power than by 1. This is second power, this is first power, is higher by 1. So this is the case, you can end up with oblique asymptote, which is slant asymptote. So how do you calculate that? You have to do numerator divided by denominator. And denominator is x plus 3, so I'm going to use synthetic division. 1 minus 8 for numerator. And you need a minus 3. X plus 3, let denominator equal to 0, solve for x. Okay, synthetic division, multiply, add, multiply, add. So we got the remainder. So leave it as a coefficient, throw x there. That's your quotient. So x minus 2 plus minus 2 over x plus 3. Okay, this is a quotient, which is y equal to x minus 2. That's going to be your oblique asymptote. So we don't have a horizontal asymptote here, but we have oblique asymptote, which is equation y equal to x minus 2 is the equation. They do want intercept, so why don't you calculate x-intercept? So that's the part. Do you remember? By now, hopefully you remember the shortcut. How do you find the x-intercept? Let numerator equal to 0. Let numerator equal to 0. So if you do remember x-intercept here, you just let numerator equal to 0. If you don't remember that shortcut, then you just plug it in y equal to 0. So plug it in y equal to 0, x squared plus x minus 8 all over x plus 3. Solving for x, what do? Get rid of x on denominator. So multiply by denominator both sides. So when you cancel things out, this appears. 0 times whatever is 0. So if you do remember x-intercept shortcut, which is what? X-intercept, let find the zeros of a of x, the numerator equal to 0, that's the shortcut. Numerator equal to 0, then you can skip all this process when you find x-intercept. Okay, I did try to factor this. It doesn't work. Okay, 1 times minus 8, 2 times minus 4, change the number. You will never be able to factor this. So I'm stuck. What do? You have to do quadratic formula. A equal to 1, B equal to 1, C equal to minus 8, A, B, C, X equal to minus B plus minus square root of B squared minus 4AC all over 2 times A. You have to use a quadratic formula. More work, it's not that bad. Minus B plus minus square root of B squared minus 4AC. I usually set up with a parenthesis like that. BBACA, B, ACA. A is 1, C is minus 8. So X equal to what? Minus 1 plus minus. You got 1 squared plus 32. So calculate what's inside root. Okay? So some of my students get confused. Whenever they have a calculator, they type the whole thing. No, don't type the whole thing. Type what's inside the root, which is this. 1 squared minus 4 times 1 times minus 8. Type only inside using your calculator. Then it becomes 33. Okay? Over 2. 2 times 1 is 2. So that is your x-intercept. So do you remember? I said usually I ask you to do this without graphing calculator, but still you can get the decimal value using your calculator. You can just type it in. So type 1 with a positive. Type 1 with a negative because you will need the decimal value. So type it in, x equal to this, x equal to this. So type into the calculator, I think they did it. So they got this one as minus 3.37. They got this at 2.37. So I'm going to use this number there. So x-intercept, I got what? 2.37, 2.4, I mean, 0. And I got minus 3.4, comma 0. So I got 2 x-intercepts. Okay, you have to calculate y-intercept. Y-intercept is what? Plug it in x as 0. That's easier to plug it in to the original equation. So y equal to plug it in x as 0. So 0 squared plus 0 minus 8 all over 0 plus 3. You got y equal to minus 8 thirds. That's like minus 2 point some decimal. Okay. So you got y-intercept is 0, comma minus 8 over 3. Okay. I think we are ready to graph. So pro y-axis, x-axis, put the vertical asymptote. We got vertical asymptote x equal to minus 3. So put a dashed line. You have to plot oblique asymptote, slant asymptote. Okay, -2 is y-intercept. -2 is y-intercept right here. Slope is 1, 1 over 1. 1 as a slope is equal to 1 over 1. That's a rise over run. So starting from here, rise is positive 1, go up 1. Run is positive 1, go right 1. So you get the idea. 1, up 1, right 1. So your slant asymptote will look like something like this. Plot all points you know. We have x-intercept, 2 of them, 2.3, 2.4, 0, 2.4, 0, 2.4, 0 right here. Minus 3.4, 0, minus 3, minus 3.4, 0. Okay. That is pretty good. Because right side of this vertical asymptote, we have two scenarios. You can have graph like that, or we can have graph like this. Having one point like this, you already know. So that you have action something like this. Of course, you can get more points by plugging in. Oh, well, we have a y-intercept. That's good. 0, minus 2 point something. 0, minus 2 point something. So you know we have one more point here. That's very good. So you will have points on the bottom. So your graph would look something like this. Okay. And on the left-hand side, you have two choices. You can have graph like that, or you can have graph like that. Having one point here tells you, okay, you will have graph like this here, passing through. And that will be graph. And so let's take a look at it. Yep, that's the graph. Okay. Okay, so they are asking you to do something similar. You should pause the video and try. Here, vertical asymptote, you can do denominator equal to 0. So vertical asymptote, denominator equal to 0. So you got x equal to -2. So vertical asymptote x equal to -2. And they want intercepts, and so domain, I'm not gonna write. They didn't ask. Horizontal asymptote, if you look at it, we have a higher power on numerator. What does that mean? We're not gonna have a horizontal asymptote, and it's higher by 1. Meaning you will end up with oblique asymptote. Oblique asymptote. How do you find it? Synthetic division. So you're gonna do 1 minus 3, 1 divided by -2 here. Because x plus 2 equal to 0 will make -2. Synthetic division. That's the remainder. And leave it alone, put x, get x minus 5. So y equal to x minus 5 will be oblique asymptote. Yeah. Y-intercept, x-intercept. Okay. So x-intercept, hopefully you remember shortcut, numerator equal to 0. X-intercept, numerator equal to 0, solve for x. Okay, this is not factorable. If you try it, you will fail. So you have to use a quadratic formula. A equal to 1, b equal to minus 3, c equal to 1, x equal to minus b plus minus square root of b squared minus 4ac all over 2 times a. So b, b, a, c, a, b, b, a, c is here. Double minus makes positive. You do want to type what's inside the group. So 9 minus 4 will make a 5. That's not that bad. All over 2 times 1 will be 2. That's your x-intercept. And yeah, they got x-intercept there. Y-intercept, you plug it in, x is 0. X is 0, x is 0, x is 0. So all that is 0. You get 1 over 2. 1 over 2. 0, 1 over 2. Y-intercept 0.5. Okay. Example 5. Determine vertical asymptote, horizontal asymptote, holes. We haven't dealt with the holes yet. Hole, intercept, then graph it. So first thing you have to do, you have to factor numerator, factor denominator. Numerator is x squared minus 9, which is the same as x squared minus 3 squared. So you get to use the formula, which is a squared minus b squared formula, parenthesis, parenthesis. You have to memorize this. So you can apply this, x becomes a, 3 becomes b, it becomes x plus 3, x minus 3. I factor the numerator. Okay, denominator you have to factor as well. X squared minus x minus 6. 1 times 1 makes 1. 2 times 3 makes 6. I need a minus 6. So you need a minus somewhere. Multiply these two. 1 times minus 3 makes minus 3. 1 times 2 makes 2. Add them, you get minus 1. This number should match coefficient of x. And they do match, meaning we found the combination. So throw x here. So what x times x becomes x squared. Top floor, bottom floor. Put the parenthesis, write it down, x plus 2 parenthesis, x minus 3 parenthesis. So that's the factoring of denominator. So I factored it. So h of x equal to x plus 3, x minus 3 all over x plus 2, x minus 3. Okay, this is the very first question. You're gonna look at the whole. If you look at my paper here, did you notice my whole was listed very first? Because you have to check whole first before you go over anything else. So when do we have a whole? Look at the numerator denominator. Don't you see we get to cancel x minus 3, x minus 3. We have exactly the same factor numerator denominator. That's where you're gonna have a whole. So if you look at my part 1 video, I said the whole, the common real zeros of numerator denominator. That's what I meant. We got zeros of 3, numerator denominator. That's when you get to have a whole. So be careful. You get to cancel this. So after you cancel, your h of x is updated to h of x is now x plus 3, x plus 2. But do you remember that was the original function of f of h of x? The one you get to cancel, that's when you're gonna have a whole at. So you have a whole at what? The one you get canceled, numerator denominator. So that part, you let that equal to 0, solve for x. So x equal to 3. So 3 is x coordinate of a whole. You need to get the y coordinate. How? plug it into here. The one after you cancel, plug it in. So y equal to, plug it in 3 there. So y equal to what? 6/5. So 6/5 is your whole. So you got 3, 6/5. Okay, after that, everything else is the same. And you're dealing with this after you cancel things out. So let me continue with the vertical asymptote here. Vertical asymptote what? Denominator equal to 0. So x plus 2 equal to 0. X equal to minus 2. So you got vertical asymptote is what? X equal to minus 2. Did I ask a domain? Yes. So minus 2 here. Domain is what? X cannot equal to minus 2. Horizontal asymptote. You deal with this. Power of x, same power. So it should be 1/1. Horizontal asymptote, y equal to 1/1, which is 1. Yeah, I didn't ask for the range, so skip that. X-intercept, y-intercept. Okay, you should remember by now the shortcut for x-intercept. X-intercept is what? Numerator equal to 0. So I'm going to let numerator equal to 0 solve for x. So x equal to minus 3. So x-intercept is what? Minus 3, 0. Y-intercept is what? You plug it in x equal to 0. So y equal to, plug in x equal to 0. Plug in x equal to 0. So you got y equal to 3/2. Y-intercept 0, 3/2, which is 1.5. Okay, then graph it. I think we are ready. So on a graphing paper, set the vertical asymptote, horizontal asymptote. Vertical asymptote is what? Minus 2. So you got dashed line and x equal to minus 2. Horizontal asymptote is y equal to 1. So you have horizontal line, y equal to 1 here. Plot all the points you know. So you got x-intercept minus 3, 0, minus 3, 0 right here, x-intercept. Y-intercept 0, 1.5, 0, 1.5. Okay, that's pretty good points. Why? Right side of the vertical asymptote, you have this or this. We have a point on top, so that tells me I'm gonna have graph like this. Before I continue, I'm gonna check where's my hole. 3,65. So I have a one more point, which is a hole. 3, that's like 1.2. 3, 1.2 is somewhere over here. So I have a hole. Okay, so you connect them nicely. So you have graph like this, and you have graph like that. So key point here is making a hole like that. I need to see that hole when you graph it. And with this, that will be a complete graph. Yep. That's all.